Hello, welcome to the video on mass mole conversions. It's sort of a continuation of a series of videos, and at this point you hopefully know how to use Avogadro's number. So we've been using it. We know that 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. And we've also learned how to add up molar mass, and molar mass is in grams per mole. Okay, that's the units that we use for that. And so if we're trying to convert, so let's pretend here that we want to convert from grams to atoms or molecules. Okay, and so we need to think about the conversion factors that we know and that we understand. And so if we have aspirin, for example, we used this in a previous example. Okay, aspirin is C9H8O4. If you add all of those up on the periodic table, add up the atomic weights, you get a molar mass of 180.2. All right, so we know that that is the molar mass, so 180.2 grams per 1 mole, since the periodic table is based upon 1 mole. All right, because 1 mole is the same thing as 6.02 times 10 to the 23rd molecules, we can then make a conversion factor where 180.2 grams of aspirin, you have 180.2 grams for every 6.02 times 10 to the 23rd molecules, okay, because 1 mole is the same thing. Okay, so here's our new conversion factor. Okay, so the best way to look at this is just to work a problem. So if we have a 325 milligram tablet of aspirin, there's its molar mass. You should be able to add that up at this point. Okay, and we want to know how many molecules are in it. So right away I know that my number is going to be pretty large because molecules, there's thousands of these in our molecules or in our samples, excuse me. So basically we want to identify what we've originally have. So we have 325 milligrams of aspirin. Okay, everything that we've been looking at has been in grams. Okay, and so I'll just show you a quick little way here. But if you're in milligrams, you need to move that decimal back to the left 3 places. So you need to go 1, 2, 3. Always does that to me. So 1, 2, 3. So you have 0.325 grams. Okay, all I did was divide by 1,000. So that's just sort of a simple way. I'm going to show it anyways. But so we're going to need this conversion, or you can just move your decimal like I showed. 1,000 milligrams in a gram, or 1 gram in 1,000 milligrams. Okay, in order for it to cancel, you need to divide by 1,000 milligrams. Okay, and then we're going to need our conversion factors, where we have 180.2 grams per 6.02 times 10 to the 23rd molecules. Okay, we need a common relationship because we're given grams and we're looking for molecules. And this, we used to just plug in 1 mole. Okay, but we know 1 mole is the same thing as Avogadro's number. So here we have another common relationship. Okay, and we're going to choose this one here to get from 325 milligrams to grams, and then we're going to have to choose this conversion factor because we start with grams and we need those to cancel. Alright, so let's put this all together. We're given 325 milligrams of aspirin. We just have to get that to grams because we know our relationships are in grams. So we need to do that. So we write out what we know, 325 milligrams aspirin, divide by 1,000 milligrams so that we cancel. Okay, that equals 0.325. Okay, so you could do that separate if you wanted to, but here we're putting it all in one. Okay, and now we have grams of aspirin. Okay, so I like to write the compound out too, so you could write C9H8O4. So we converted from milligrams to grams because we know our common relationship is with grams and molecules. Okay, and so now we're set up to do a second step. So this was our first step. And now we have a second step. And because grams of aspirin's on top, we have to have grams of aspirin on the bottom. And we know that we have 180.2 grams for every 6.02 times 10 to the 23rd molecule. So grams cancel, and we're left with 1.09 times 10 to the 21st molecules. All right, so you convert 325 milligrams, you convert to grams, and then now we have a second step, and we use our common relationship where we added up the molar mass of aspirin, and we know that we have 180.2 grams per 1 mole always. That's what our previous video discussed. But because 1 mole is equal to Avogadro's number, which is 6.02 times 10 to the 23rd, then we can also plug that number here, and that's how we get our common relationship. And we had to plug it in with grams, had to flip it over because grams has to cancel. So grams is in the denominator and molecules in the numerator. All right, when you plug this in your calculator, 325 times 6.02 times 10 to the 23rd divided by 1,000 times 180.2. Okay, when you do this, you need to use parentheses around all of your numbers and be sure you get the correct exponent. If you get the wrong exponent, you've plugged it into your calculator incorrectly. All right, thank you. I hope this helped.